Let's first talk about question number 16. Yeah. So how are we going to solve this question? Have a look at this question. Read it, please. First, you try to give me an answer, then I'll help you out. Figure 5.1 shows an aerial view of wavefronts passing from the open sea into an outer harbor. So this is a gap. This is a wider gap, and we know that in narrow gaps we have more waves, more curves than the wider gaps, right? Yesterday only we discussed about this. And then the outer harbor has these types of diffraction. What type of diffraction will we witness in the inner harbor? Let me know if I make the diagram wrong. Okay, if I say that the waves are going to look uh, like this, will I be correct or wrong? Right, because the curves will be more. Yes. So diffraction. Yes, this process. This is known as diffraction. Yes, the spreading of waves. I made you write the definition as well. So this is what you need to just draw. Okay. So what is this process called? It's called the diffraction. So here for question number 16 part 1, our answer is going to be diffraction. Now on figure 5.1, carefully complete the wave pattern as the wavefront progresses. So I just drew the pattern for you. We will have more curves. Okay, this is what you need to draw. Just make sure you follow the rule that they are telling you to follow. See, show the rest of the wave pattern in the outer harbor and 3 wavefront in the inner harbor. Okay, so what do we need to show? Show the rest of the wave pattern in the outer harbor. So you just need to make sure that the distance, see this distance needs to be the same. So you have to take the same distance and then draw another line like this first. Okay, once you have drawn this, after that you need to draw, what will you witness at the inner harbor? More curves. So these will look like this. They're telling you to draw only 3 wave fronts. So you need to draw only 3 wave fronts. Make sure that the distance remains the same. Do you get it? I've drawn 3 wave fronts. This is 1, 2, 3, 3 wave fronts, and this is what it will look like. Any confusion over here? All right. So see, easy 4 marks, 3 marks for here, 1 mark for here, 4 marks. Now have a look at this question. Figure 5.2 shows an aerial view of wavefront in deep water approaching a region of shallow water where they travel more slowly. So they are traveling more slowly. So that means the speed is slow, the velocity is slow, and when the velocity is slow, the lambda is also small. It also decreases. Yeah, we discussed this earlier. So we are going to show that the water is entering the shallow region. And what did I teach you? Try to recall. When we go in the shallow region, we have a refraction. See, this is a bent surface, so we will witness refraction, and the wave will bend towards the normal or away from the normal. Where will it bend? Then we go into shallower region. Where should the wave bend? Should it bend towards the normal or away from the normal? Have a look at your notes. Let me know quickly. Yes, very good. It will bend towards the normal. So what is the first thing that I must draw? I should first draw the normals first, right? So draw 90-degree lines like this over here first. That would be representing the normals. Do you get this part? Okay, after this, you have to bend the lines towards the normal. How would you bend it towards the normal now? Hmm. At what angle? Hmm. So where should it bend? This is the, see, these are the angle of incidence. So somewhere over here, the bend should be here, right? And towards the normal. That means if I draw the line like this, it would be wrong. This is away from the normal. So my line needs to be towards the normal. That means the bend should be like here in this direction. Okay? So the bend needs to be somewhere like this, this. So that this angle, 1 minute, so that this angle is less. The angle of refraction is lesser than the angle of incidence. Okay? So that's why this is how I will bend the line. Any confusion over here? The blue color is the normal, the red color are the waves that are going to bend towards the normal. So see, name the process that occurs as the wavefront passes from deep to shallow water. What is the process? What's happening to the waves? The waves are refracting or reflecting? Refracting. So what do we say? This process is known as refraction. That's it. Easy. Okay. Now, complete figure 5.2 to show possible position of the five wavefronts in the shallow region. I already drew it for you. This is how the waves are going to look like. Any confusion so far? You also have to give this question and try yourself later. Just draw a straight line like this, these horizontal lines, and then this line, and then try to draw the wavefronts yourself as well. All right. Do you have a printer? Okay, so it's better if you take a printout of this. Like questions are like these. It's better if you solve these questions on the paper itself. It will give you a better understanding of how you will draw these wavefronts. So just see, the wavefront AB is traveling in the region P towards region Q, where the water is shallower and the wave travels more slowly. Oh, okay. I guess. Do you get my point? The wave is traveling. Yeah, I will repeat it again. I drew all these waves again here, and then I drew the normal. Then I note down over here that you have to make this line identical over here in this part. These parts are not important. This line is very important. You have to basically draw this line exactly over here. All right. So once you have drawn the line, you notice that after drawing the normal, you notice that this angle of incidence is smaller than the angle of refraction from C to D. And then you have to choose which should be the correct answer. Is this the correct answer or is this the correct answer? You get my point? Now you have to choose which will be the correct line. Will it be CE or will it be CD? CF cannot be the answer because it is directly perpendicular to the wavefront. So it cannot be the answer. This line can never be the answer. So it is either CE or CD. How would I choose the correct answer? Through this data that is provided. They are saying that it is traveling in region P where the water is shallower and the water travels more slowly. That means we are in shallow region. And this region, the region in which we are going to enter, that region is the deep region. So when the water moves from shallow to deeper region, it will bend away from the normal. Got it? So that's why our answer will be CD and not CE because CE is towards the normal. This should have been the answer if we were entering where we were if we were entering the shallow region. Got it? But we are going into a deeper region. That's why the answer is CD, away from normal because we are entering the deeper region. That's why your answer will be CD and not CE. So straight in which direction will the new wavefront be? It's going to be CD. Got it? Explain your answer. How will we explain it? What will we write? Hmm. Yeah. You have to just explain. Look, you have to just simply explain that why is this direction that is shown in the paper, what is causing this direction? You have to just tell them that what happens to the wave fronts. You have the first thing that you need to tell them is what, that whenever we go from one region to another region, what would happen? The wave front will bend, it will refract. Okay, so you have to say that the waves refract when they enter different regions. Okay, now as you know that Q from B, all right, this point was B, is going to spread away from the normal. So why? Because as region Q is deep, as region Q is deep, so waves bend away from the normal. Okay, and then what else do you need to say? Hmm. Yeah, so see, all these lines are going to be like spread out like this. One minute, region P, yes. You have to basically draw straight lines like this, okay? Like this. Use a ruler to draw it. I'm just drawing rough drawings. Make sure that the distance is exactly the same. All right? This is how it will look like. Okay, what else can you write then? Yeah, this on CN, CND and ANB. Um, yes, you can say that. And what else? Hmm. Yeah, just simply all you need to just say is, look, we already mentioned that the wave is going to correct its position to CD. So just simply say that the wave AB, wavefront AB, this is AB, right? Just say that wavefront AB will move in the direction of wavefront CD. That's it. Okay. Understood? That's it. This would give you 4 marks. Any confusion over here? Okay. Those waves after a change is made the way the tank is set up and the experiment is repeated. Okay, they are repeating the experiment and now they are saying that the wave from position AB in the region P now moves in the position CG in the region Q. State the change that has been made and explain your reasoning. If you see properly, these are totally identical. There is no bend. Do you see any bend between CG and AB? Like if there was a bend, this line could have been it should have looked like this or like this, right? But it is exactly the same. See, there is no bend. What does it mean? When there is no bend, that means there is no change in medium. There is no change in the region, right? The depths are same. When will we witness refraction? Whenever we go from a deeper region to shallow region or from a shallow region to a deeper region. But these two lines are parallel to each other. Look, the distance between these two lines is going to be the same all over. Therefore, we can say that the region is same. It is not changing. Okay? Over here, see, this was a bend. Notice CD and AB. AB is like this, CD is something like this. It is bent. Do you understand this question? Okay, so over here, these two lines are totally parallel to each other if you notice. So you can say that as these two lines are parallel to each other, even though when we entered region Q, this means that the water over there is not deep. It is the same as it was in region P. Got it? So just explain over here that, 1 minute. What is the change first? There is no change. This is what we will say. State the change that has been made and explain your reason. No change has been made. Okay. And how would you explain it? That the both regions have same depth. Both the regions have same depth. That's why there is no refraction when the waves entered region Q. Understood? If there's any confusion, feel free to ask me. I'll explain to you again. All right. Now after this, we have to solve question number 18. A wave passes along the surface of water in a ripple tank. Describe the motion of a molecule on the wave as the wave passes. Yeah. Do you understand what I'm saying in this question? A wave passes along the surface. Yeah. They're talking. Yeah. So how? Yes. Just explain the motion. That what type of wave will we see? Will it be a longitudinal wave or will it be a transverse wave? Look, first tell me, look, this is the ripple tank. I told you about ripple tank that it creates ripples. So water waves. Ripple tank will create water waves, right? So what are water waves? Are water waves transverse waves or longitudinal waves? Yes. Water waves are transverse waves because they create this crests and troughs, which means that the direction of vibration is perpendicular to the direction of the wave. Okay? So what will I write here in the answer? I'm going to simply say that describe the motion of molecule on the surface as the wave passes. What will you say? That the molecules will move how? How should they move? They should move perpendicular to the direction of the wave. Got it? The molecules will move perpendicular to the direction of wave. Molecules are the particles. The particles will vibrate perpendicular to the direction of the wave. Got it? Okay, part B. Figure 7.1 shows a view from the above of water waves approaching a narrow gap in a barrier. The water on the both sides of the barrier has the same depth. Now what? It has the same depth. Okay, this part. All right. So diffraction is occurring here. We have a narrow gap. All you need to do is draw what? The pattern. How should you draw it? Tell me. Will we witness more curves or less curves? Hmm. Is this correct? So just make sure that you draw this neatly. I'm just drawing it roughly for you. And you have to draw it till point P like this. You have to make sure that you draw one curve that crosses point P. Understood? Now they are saying state the process by which waves arrive at point P to the right of the barrier. Which process is this? Refraction or reflection or diffraction? Diffraction, yeah. Simply we write diffraction here. Okay. Now this is an easy question. What do we have in this question? We have the wavelength, we have the speed, and we are asked to find the frequency. What is the formula for our wave speed? V is equals to F lambda, right? What is V? V is 12. F is, okay, why am I not changing the values from centimeter to meter cube? Because the distance is also in centimeter and the speed is also in centimeter, so I don't need to change it into meters. All right. So 12 is equals to, we need to find the frequency, lambda is 1.4. So F will be equal to 12 upon 1.4. What does it give you? Please calculate it and let me know. Okay, 8.57 hertz. Got it? That's it. Now do solve all the questions, okay? I want you to solve question number 12 and 11 later on. Let's just start with chapter light now.